Hello everyone, here is a question from the basic concepts of chemistry. When 6.3 gram of sodium bicarbonate is added to 30 gram of acetic acid solution, the residual solution is found to weigh 33 grams. The number of moles of carbon dioxide released in the reaction is how much? Let us first write the reaction. Sodium bicarbonate reacts with acetic acid. If sodium bicarbonate reacts with acetic acid, we will get sodium acetate plus water plus carbon dioxide gas. Here what they mean by residual solution is these two, sodium acetate and water, that is the residual solution, because CO2 is a gas that will be released. The residual solution weight is given as 33 grams. Sodium bicarbonate weight is given as 6.3 gram and acetic acid weight is given as 30 grams. We can easily find the answer by calculating the difference in weight. On the reactant side, the total weight is 36.3 gram. On the product side, one weight is given, the residual solution weight. So 36.3 minus 33, and that would be 3.3 grams. So once we know the number of grams, then all we need to do is find the molar mass of CO2 and find the answer. But we are not going to solve this problem through this way. Let us assume that the residual solution weight is not given to you. In that case, how you will solve this problem? In that case, you can still solve this problem if you understand the concept of limiting reagent. We have two reactants here. So one of them should be the limiting reagent. Whichever is the smallest in terms of mole ratio, that's what we call it as limiting reagent. The reaction is already self-balanced. We have 5 oxygen atoms on the reactant side. We do see 5 oxygen atoms on the product side. We have 5 hydrogen atoms on the reactant side. We do see 5 hydrogen atoms on the product side. 3 carbons, we do see 3 carbons here, 1 sodium, and therefore the reaction is already self-balanced. Therefore, if you write down the stoichiometric moles, this is the way we write down the stoichiometric moles. 1 by 1 number of moles of sodium bicarbonate. Whatever is the coefficient that you have, you just need to bring it down here. So 1 by 1 number of moles of acetic acid, 1 by 1 number of moles of sodium acetate, and then 1 by 1 number of moles of water, and 1 by 1 number of moles of CO2. Once you find the limiting reagent, then the stoichiometric moles of that you can equate with the number of moles of CO2. That way we can easily find the answer. So let us first find the number of moles of sodium bicarbonate and acetic acid. For that, we need to know the molar mass of both of these molecules. So for sodium bicarbonate, the molar mass is going to be 1 times sodium 23, 1 times hydrogen 1, 1 times carbon 12, and then 3 times oxygen, 3 times 16, 48. And therefore this is 14, remaining 1, so 5, 7, 8. So 84 gram per mole. Number of moles equal to mass divided by molar mass. Mass given is 6.3 gram here, and molar mass of sodium bicarbonate is 84 gram per mole. This is 9 times 7, so 0.9. This is 12 times 7. Therefore, we can write this as 9 times 10 to the power minus 1 divided by 12. So this is 3 by 4. That means 0.75, but we do have 10 to the power minus 1, and therefore 0.075 moles. That's the answer for number of moles of sodium bicarbonate. Acetic acid, molar mass, carbon 2 times 12, 24, and then hydrogen 4 times 1, 4, and then oxygen 2 times 16, 32, and this will be 10, remaining 1, so 60 gram per mole. Therefore, here the number of moles will be 30 gram divided by 60 gram per mole. Therefore, this is simply 1 by 2 and therefore 0.5 moles. So, in terms of mole ratio, which is less? Sodium bicarbonate is less, and therefore, that is our limiting reagent, and acetic acid is the excess reagent here. This means we can write that number of moles of sodium bicarbonate is equal to the number of moles of CO2. That means number of moles of CO2 is going to be 0.075 moles. Now, through the weight, the difference in weight, what was the mass found? 3.3 gram for CO2, isn't it? And therefore, the number of moles of CO2 is 3.3 grams. Molar mass of CO2 is 44 gram per mole. Therefore, this is 3 times 11, so 0.3. This is 4 times 11, so this is 3 by 4 into 10 to the power minus 1. So, this is still 0.075 moles. So, that is what we found here. So, even if the residual weight is not given, you can still find the answer, provided if you understand the concept of limiting reagent.